This is the real science of climate change. This is not Rush Limbaugh. This is not Al Gore. This is the real science using real data, and it's not straightforward, as you shall see. For the last 4 million years, the climate has been going in and out of short warming periods and long ice ages. This graph shows the last 400,000 years. If you look, it reads from right to left. That is, the now is on the left and 400,000 years ago is on the right. As you can see, we've had these short warming periods, long periods of ice age, short warming periods, long periods of ice ages. It's interesting that it's dustier when it's colder and less dusty when it's warmer, which would indicate when it's warmer there are less deserts. As you can see, there's a graph there showing the CO2 level in the atmosphere, and the CO2 tends to follow the temperature rather than lead the temperature. So it would seem from this graph that CO2 is an effect rather than a cause. Also, if you notice, we are far overdue from another ice age. When climatologists first saw this data, they sort of hit the panic button. Back in the 40s, late 40s, early 50s, and into the 60s, there were popular shows and popular science articles that predicted we would quickly be in an ice age. And these things looked reasonable at the time. There are, depending on how you count them, about 8 factors. The most important factor is the output of the sun, and what I am going to show you is the overall effect of these factors. One equation, we have the sun shines on us. A lot of it is reflected back into space. What isn't reflected back into space heats the Earth, and the Earth, being relatively warm, radiates out into space. The temperature of space is about 460 degrees below zero, very cold. If you're out at night and it's a clear night, you can feel how cold space is. So we have the sun shining, reflecting most of the energy back out into space, and then the Earth radiates out into space. This is data that shows you the last 400 years of sunspot observations, and it's been determined that sunspot observations and sun output are very closely correlated. And between 1650 and 1700, we had the Little Ice Age. In the Little Ice Age, we had worldwide famine. It was cold all over the earth. The sun came back for a while. We had the Dalton minimum. And then recently, we've had the modern maximum. Very recently, it looks like we're going back and not going to have as high a level of sun output. But prediction is not good in the sun science. So we don't really know what's happening. We do know whatever it is, we're going to feel the effect. This is the recent data at 55 years in radio emissions, and it shows that it's tapered off, and this is also pretty well correlated with sun output. There are orbital effects. The Earth moves around the sun, and this orbit can be circular, or it can be more oval shape. That is, it can be more eccentric. So when the orbit is circular, we have warmer climate than when the orbit is making an oval. When it makes an oval, the time away from the sun is more than the time near the sun, and there's net cooling. There's an axis tilt effect, a precession effect, and there's also an effect of the Earth being in or out of the plane of the galaxy. There's recent work done at CERN that shows this can be very important. As the sun moves out of the plane of the galaxy, we have more cosmic rays, and when we have more cosmic rays, we have a change in the upper atmosphere that will cause global cooling. So as we move out of the plane and as the eccentricity increases, we will have global cooling. Things in the atmosphere. The major greenhouse gases are carbon dioxide and methane. These things, the more they are in the atmosphere, the warmer we will be. The major anti-greenhouse gas is sulfur dioxide. Sulfur dioxide comes from volcanoes mostly, so when a volcano blows up, we have a cool period. We have had relatively few volcanoes recently, but some of the ones in the past have created dramatic climate effects. Tambora and Krakatau, both Indonesian volcanoes, created what were then called the years without summer. This can and actually will happen again. We have some of these big supervolcanoes will go off, and when they will, and when they do, we will have this period, a year, maybe even more, of very low temperatures. We'll lose a lot of the crops. We'll have worldwide famine. Diesel engines make soot. Soot lands on ice. That's warming. The fine dust in the atmosphere and the smoke actually is cooling, and clouds do both. When we had September 11th and grounding of aircraft, this actually was measurable. We learned some climate science during that period. This is Mauna Loa carbon dioxide measurement. As you can see, it goes up and up and up and up. It keeps going up and has been for a long time. When scientists first saw this, they thought, oh no, we're doomed. We're going to cook because of the greenhouse effect. And scientists such as Mann, Professor Mann, decided that they were going to spread the word and alarm everybody. And then when the data didn't look quite right, they just didn't want to go back and say, well, that's not really true. They wanted to fudge the data to try to keep people alarmed at this. They had good intentions, but whenever scientists start fudging data, the results are not good. This is some recent climate data from the major players in this business. And you can see that this data, and then we'll just compare it to this data, you can see that there's not a correlation. It doesn't correlate, which tells you that all these other effects are overwhelming the effect of carbon dioxide. Some people at NRL and NASA tried to put together equations to predict what would happen. Well, the only problem with prediction is it doesn't necessarily go that way. They were able to predict the past with 70%, 76% accuracy, and that really isn't very good if you're a statistician. So even their model didn't do well predicting the past. Predicting the future is something else again. Let's look at the sum of all of this. We have a low sun output right at this moment which is starting to cool the atmosphere. We have higher carbon dioxide, which is heating. Lower levels of sulfur dioxide, we haven't blown a volcano in a while, that's relatively heating. We have lots of fine particles. China, if you've been to China recently or in Southeast Asia, is just constant smog. And that's actually cooling. We have large particles from diesel engines and stuff up on the poles, and that's heating. The orbital we're in now is warming, but we're headed towards cooling. Paving and building and, interestingly enough, solar panels are warming. Solar panels absorb a lot more. So if we solar panel a desert, we're going to cook. The conclusion: the climate has always been changing. It always will be changing. We are having an effect, but it's currently overwhelmed by natural processes. With enough factors, we're able to predict the past in the short term with 76% accurate. The future is less predictable. Some changes can be fast, so we need to think about how we're going to handle this. And it's particularly the arrival of ice ages. Ice ages arrive quickly. What should we be worried about? Well, we need to be worried about nuclear weapons in the hands of lunatics, killer asteroids and comets, gamma ray bursters, supervolcanoes. All of these things can get us. And even a mini ice age would cause global famine. Runaway global heating, melting the poles, would be a problem. Modest increases in global temperature would increase arable land and food production, and actually would be good. If we had a little bit increase in global temperatures, we would have better climates in northern Russia and that area, and in northern Canada, and actually in parts of Australia. So a little bit of heating would be good. A lot of heating is bad. Cooling is even worse. What can we do? If we want to reduce the sea level, we can flood the Equator Depression. It's 463 feet below sea level. It's a giant area. It's south of the Mediterranean. We could increase the level of the Dead Sea. We could build dams. All of these things are marginal, but they all would have a significant effect just because it's a multiplying effect. If we're concerned about carbon dioxide, we could seed the sea with iron. One atom of iron has been predicted to take out 400,000 molecules of carbon dioxide. We could do something that would make the nature guys a little nuts. We could bury yard waste and organic waste. If you look at like the rainforests and all, they are carbon neutral. They're not the lungs of the planet. Uplands have things rotting, generating carbon dioxide just as fast as the plants are producing carbon dioxide. So that doesn't help as much. If we cut a tree down, turn it into paper and bury it, that actually does take carbon dioxide out of the atmosphere. The important thing is wealth. If we have the resources, then we can do something about it. And we need to prepare in both directions. And it's relatively easy to fix global warming compared to fixing global cooling. Thank you.